2, we looked at linear functions. So we'll do a quick review for your final. I think we started with slope-intercept form. So you should remember slope-intercept form can be written like this, y equals mx plus b. Sometimes they use different letters or change the order. So you might also see it y equals ax plus b. Or a, we'll change this, a plus b to the x. Either one, the slope is the number next to the x. So the one I think that, at least when I teach it, we look at y equals mx plus b. Slope is the number next to the x. B is your starting value at time 0, or we often call it the y-intercept. Okay, so let's do an example of something that's linear. Let's say we have Joseph, and he can rollerblade 16 miles in 2 hours and 24 miles in 3 hours. What are the independent and dependent variable? So we're looking at distance and time here. The independent variable is time, and the dependent variable is distance. The distance that Joseph travels depends on how long he's been rollerblading. So again, distance, this is in miles, and, or sorry, time is in hours. Change that. And distance is in miles. All right, what would be a function to represent the situation if his rate remained constant? Okay, so we need two things here. We need the slope and the y-intercept. Let's say he starts at, like his house, we'll call that distance 0. So the y-intercept would be 0, the distance he's traveled at time 0. But we would need a slope. Okay, so let's figure that out. Slope is rise over run. Let's write these as coordinates. It's easier for me to see them as coordinates. So in 2 hours, that comes first because time is the independent variable. In 2 hours, he travels 16 miles, and in 3 hours, he travels 24. So you could graph this to figure out the slope. I'm going to use rise over run, or slope formula. So I'll call this x1, y1, x2, y2. And then if you remember from geometry, slope is y2 minus y1 over x2 minus x1. So this is just figuring out rise over run algebraically. So if I plug in, we get 24 minus 16 over 3 minus 2. And that will give us 8 over 1. So he travels 8 miles every hour. Okay, so again, what does the slope stand for in this situation? His distance, the distance he travels per hour. So distance he travels per hour. All right, let's write the actual function up though. Let me erase what we have here. All right, so our slope is 8. We'll write y equals, change colors here, 8, and slope goes next to the x. You can write the plus 0, but since it's plus 0, we don't need it. Okay, so every hour, Joseph travels 8 miles. That's what that would stand for. Okay, to review, if you want to find slope in an equation, you have to get y by itself, and the number next to the x is the slope. So let's do an example here. Write the equation of the line that passes through 1, 4, and it's parallel to this line. All right, we need to do two things, slope and y-intercept, and we should always start with our slope first. So let's look at our slope. All right, our slope is parallel to this, x minus y equals 10. So let's get y by itself and figure out the slope. So I'm going to add y to each side. We get x equals 10 plus y. I will subtract 10 from each side. So you have x minus 10 equals y. The reason I did that is I want the slope. The slope is the number next to the x. If there's not a number next to the x, the slope is 1. So here our slope is 1. Second step is we're going to plug in our point. So I'll call this x and y. And we're going to plug in the slope and solve. So we have y equals mx plus b. So I'm going to plug in 4 for my y value. The slope is 1, x is 1 plus b. And now we solve for b. So we have 4 equals 1 plus b minus 1 from each side. B is 3. Okay, so first step, find the slope. Second step, plug in your point and your slope and solve for the y-intercept. Third step, rewrite the equation. So the third step, we have y equals, and it was 1x, so I'll just put x, plus 3. You could also write 3 plus 1x or 3 plus x. So there's the equation of the line that passes through the point given that's parallel to the point given. Okay, next, what are the slopes of the following lines? Well, if it's straight up and down, it's so steep that we say that slope is undefined. So the slope is undefined. If it's like this, however, remember if you're counting rise over run, if we go up 0 and over a certain amount, our slope here is 0. So this is 0 slope when it's flat. When there's no slope, like you're trying to cross-country ski and there's no slope, it's flat, 0 slope. Undefined is straight up and down. All right, we also talked about correlation and line of best fit. In this graph, what are the independent and dependent variable? Well, in graphs, the independent variable is on the x-axis, so the independent is age. The dependent would be weight. Explain what the data shows us. Well, it shows us as our age, so as age increases, so does weight. Okay, so as age increases, so does weight. Draw a line of best fit. So if I draw our line of best fit here, your line of best fit does not need to start at 0. It can start at 0, but it doesn't need to. To draw a line of best fit, you want to make sure it follows the slope of the lines. Do this. And you have about the same amount of points above and below your graph. So again, it does not need to start at 0. It should follow the slope of your line. It shouldn't look like this. That would cut your line in half, same amount of points above and below, but it should follow the slope of your line. So there's our line of best fit. All right, again, you have several practice problems to try, and you can refer to Schoology if you want to see the answer. And you can add these to your note sheet if you would like them on your note sheet.